Hi everyone, in this video we're going to learn about rational exponents, so exponents that are fractions. And I just want to work our way up to this a little bit. They actually mean something that we have already learned about a little bit, so it's just figuring out what that is and then practicing with that a little bit. Okay, so to get us started, I just wanted to walk through these examples. If I multiply x to the 1/2 by x to the 1/2, I already have exponent rules that tell me how to deal with this. The exponent rules say that the powers should be added. So that's the same as x to the 1/2 plus 1/2, which is just plain old x. Another way to think about that is you have x to the 1/2 and you square it. And if you're looking at it that way, you would multiply the exponents and you would still get x to the 1. For the x to the 1/3, it's the same idea. We can either look at it as x to the 1/3 plus 1/3 plus 1/3 or x to the 1/3 cubed. And whichever way we look at it, in this case I'll do the multiplication. 1/3 times 3 is what the exponent rule says, and that would be 1. So just plain old x. And then maybe you can see where I'm going with this. For x to the 1/4, if we use the addition rule again, we would add 1/4 plus 1/4 plus 1/4 plus 1/4, and we would get 1. So what I'm spotting here is that if I square x to the 1/2, I get x. If I cube x to the 1/3, I get x. And if I raise x to the 1/4 to the 4th, I get x. And what may or may not click from that, it's okay if it didn't, but I'll tell you, is that the number that I square to get x is the square root of x. So right here, x to the 1/2 has to be the same as the square root of x. And the number that I cube to get x has to be the cube root of x. And the number that I raise to the 4th power and get x has to be the 4th root of x. So in general, what we can say is that x to the 1/n is the same as the nth root of x. And there can be a little bit of funny business if you have even roots and negative numbers. So I'm not going to get too caught up in that, but I'm just going to mention it. So if you took -2 and raised it to the 1/2, you'd have problems because that's the square root of -2, but that's a problem on both sides, so I'm not going to call it out too much here. And I'd also like to add to that a little bit. We won't only see exponents with a numerator of 1, so if we see something like a 3/4, just notice here that you can think about that as two options. So if you have x to the m/n, you can think about that as I first need to apply the 1/n and then the m, or I first need to apply the m and then the 1/n. And basically all this is based on is our multiplication property. If I have x to the 1/n and I raise it to the m, I would multiply, and that would give me m/n. If I have x to the m and I raise it to the 1/n, I would multiply and also get x to the m/n. So you need to apply two operations and you get to choose the order. I would say for a lot of our purposes, this is going to be the better order. If you're actually applying this to a number, if you raise it to a power first and get a really big number, it's going to be a lot harder to figure out if you can take the root. So I would try and take the root first and then apply the exponent. That will also save you from getting in trouble with negative numbers, so that's kind of a nice one, but truly both are generally going to be just fine. So in general, x to the m/n is the same as the nth root of x raised to the m, or the nth root of x to the m. Either one. And again, this one for a lot of our purposes is going to be the better choice, but they're both correct. Okay, let's just try and evaluate. So have some numbers raised to these fractional powers and work on figuring out what we get. This has two important parts. One is it gets us to practice all of these roots. The other is that it gets us to practice translating between fractional exponents and roots. So our first one is 81 to the 1/4, which is the same thing as the 4th root of 81. I'm asking myself here, what number do I raise to the 4th power to get 81? And again, if you don't have these memorized, it's a great thing to work on, but you can also just start working your way up. You could try, what is 2 to the 4th? So 2 times 2 is 4, times 2 is 8, times 2 is 16. That's not big enough. We can try 3 to the 4th. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is, in fact, 81. So that is the correct 4th root. So you can always check those. And I would say if you're getting stuck, if you need to use a calculator to do the exponent part, this part right here, do it. Try not to, but do it if you really need to. Don't use a calculator to do the root part or you're totally missing the practice that you get here. So work on the exponent end if you need to. All right, so we're going to mix in some negatives here and hopefully not get too tangled. Remember, a negative exponent means reciprocal. So just like I said with the m over n exponents, this is one that I would look at as two different operations. So the negative flips it over, which means we're really looking for 1 over 81 to the 1/4. Which is the same as 1 over the 4th root of 81, which is 1/3. We already figured out the 4th root of 81 is 3, so 1 over the 4th root of 81 is 1 over 3. We don't want to get tangled with negative 81 to the 1/4. So this is not a negative exponent. There is no reciprocal, and we want to be thoughtful about order of operations. If we're thinking about our PEMDAS, we don't have parentheses, but we do have an exponent. That negative sign is attached by multiplication. So the exponent would happen first. The 4th, so it's this basically, negative 4th root of 81. We know the 4th root of 81 is 3, so we'll get negative 3 from that one. So again, remember, you've got to be really thoughtful about negative signs and how you imagine that they're attached to numbers. It's kind of weird, I know, it seems like we're making it more complicated, but that'll make sure that you do things in the right order. This next one is a little bit different. We now have parentheses, so we have to go inside the parentheses first. So we do multiply that negative 1 and 81. Those are hooked together now. And then we take the 4th root. So this is the 4th root of negative 81. And we cannot take even roots of negative numbers because remember, the question is, what do I raise to the 4th power to get 81? And if you're raising it to the 4th power, it's going to become positive. So you can take a negative 4th root, that's fine, but you can't take the 4th root of a negative. That is not fine. Okay, next, 27 to the 2/3. So again, I would think about this as two separate steps. That means I need to take the cube root of 27 and I need to square. You can either square before or after the cube root. I highly recommend doing it after because squaring 27 is a mess already. That's going to get you a really big number. And then cube rooting that really big number in your head is going to be tricky. And we want to be able to do some of these in our head. I can, however, figure out the cube root of 27. I'm asking what do I have to cube to get 27? And that's going to be a 3 again. We have lots of 3's floating around. So step number 1, take the cube root. Step number 2, square it. If you split that up into a couple of steps like that, you should be able to get through these messy looking things. 16 to the 3/4. So again, I would look at that as the 4th root of 16, and then I would cube after the fact. The 4th root of 16, so I'm saying what do I have to raise to the 4th to get 16? And that's going to be a 2. So again, you can work your way up through if you want to, but it's going to be a pretty small number if I have to multiply 4 of them together, and I only get up to 16. So first take the 4th root, and then you can cube it. 2 cubed is 8. 9 to the negative 3/2. So this one I would look at as 3 steps. The negative exponent means flip it over. The 3/2 power means take the square root and then cube it. So 3 different things happening there. The square root of 9, that's at least a fairly nice one. The square root of 9 is 3. And then last step, cubing that, 3 cubed is 27. So just think about how you can break these up into simpler pieces instead of trying to think through all that as one really big tricky thing. Okay, last one, negative 81 to the 3/4. So again, order of operations, we apply the exponent before the negative, which means the negative's just going to hang out in front. And then that's a 4th root of 81. And then after we're all done, we'll cube that. So the negative sticks around. The 4th root of 81 we did work on up above, that was 3. And then we'll just have the cubing left. Once more, the negative just sticks around. It's not in parentheses. 3 cubed is 27. So you can see there's going to be lots of variety. This is something that's going to come up a lot in the later part of 141 as well. So just really try and work on those without a calculator as best you can. You don't have a ton to worry about in this assignment. It's a shorter one, so you can really spend some time thinking about some of these tricky exponents.